Welcome, welcome, my lovelies. Hopefully your test has gone well. If you're looking at this before the test, go study for the test instead. So for after the test, we're going to be transitioning from just looking at base graphs and the transformations of those. Eventually, we're going to start moving towards rational functions and the graphs of those with asymptotes. And it can get a little weird, but one of the skills that is extremely useful for that is long division, or sometimes we can use synthetic division as a shortcut instead. So in order to talk about long division, we're first going to review long division with numbers. So over here, check it out. We've got 5 into 6,608. So one of the things to note here is like the 6,608, the 0 in there must make an appearance, because if it wasn't there, then it would be a different number. It'd just be 668. In our polynomials, we're not going to see the zeros, but sometimes we're going to have to put those in. But it'll just be like right at the beginning, and then the process will continue like normal. Numbers just do us the favor of having everything organized in the correct descending order, because this is 6,000s, then 600s, 0 10s, and 8 1s. And we're going to see the same thing in our polynomials. All right, so when we do our division, first step is looking at what we're dividing by, or the biggest part of that, and the biggest part of the number, and figuring out how many times does that thing go in there, or what do I multiply by to get the biggest possible number I can subtract off. In our polynomials, it is actually going to be, what do I multiply to literally get the thing? But here, 5 can only go into 6 one time. So that's our first step. We put the 1 up there. Next, we multiply. 5 times 1 is 5. We write that down under the 6. Then, now I'm making this a deliberate separate step because in the polynomial is really helpful to have this deliberately separate. But we know in division what we do next is subtract. We're going to do 6 minus 5. I'm going to write that as a separate step because it's very helpful when we move on. Then we are going to, I put add, subtract, however you want to think about it, but we know we're doing 6 minus 5. And we get 1. And then we bring down the next number. And we start the process over again. So now we're looking at 5 going into 16. It'll go in there 3 times. Now we have a 3 up here. Next, we multiply and get 15. Then we change the sign for subtracting. Then we actually do the math and get another 1. And bring down, in this case, a 0. Now 5 actually goes into 10 nicely. And this is the kind of thing we're actually going to see in the polynomial one. Is the first part always works out nicely because we're going to have different terms. But here, multiply and get 10, subtract, do the actual subtraction and get a 0, and bring down that 8. And now the last one, 5 goes into 8 once. Multiply, 5, subtract, and we get 3. There is no other number to write down, so that means this last result here is what we call the remainder. So 6,608 divided by 5 is 1,321. Now, old school, we used to write that as remainder 3, but then we learned after a while, oh, it's actually 3 parts of 5. So 3/5. So we would also call this 1,321. I'm going to write it with words. And 3/5. Because we know the words and is just a way to say plus, which is what we're going to see when we start answering these polynomials. All right, so a more strung out review of long division, and there are other ways to think about it. Actually, a more beneficial way to think about it, if you have kids or nieces or nephews, instead of writing the 1 up top, you write 1,000. You do 5 times 1,000 is 5,000. You subtract 5,000 off, and that helps like kids keep track of the placeholder, and they don't have to think of the biggest number first. So if they wanted to do subtract off 1,500, they could start with that. So it's just a different way of thinking through the algorithm, but it's not so heavily dependent on place value the way the standard algorithm is. The standard is simply the most efficient, and you guys are like, why are you telling us this? We just want to know how to do, I know. All right. So now, same color coding. I'm going to zoom in because I write big. Also, y'all's notes got squinched together because I would recommend writing this stuff on lined paper. Having the lines where you can write each step is really nice. Freeforming it the way I do can be a little frustrating. Just FYI. All right, so now we are looking at 2x cubed minus x squared minus 12x plus 6, and we are going to divide that by x minus 2. So we have our dividend is the thing inside or would be on top of the fraction. The divisor is the thing outside or the thing that would be on the bottom if we wrote it as a fraction. Then we are going to get the quotient is our result up top and the remainder. So the first thing is determining what do we multiply by. So I say it like this because it makes sense here. What do I multiply x by to get 2x cubed? Well, I need a 2. And I already have 1x, so I need 2 more x's or an x squared. So that's the first term. Now we're going to multiply, and when we multiply, it's 2x squared times the whole x minus 2. So 2x squared times x is 2x cubed, and look, it lines up. And then 2x squared times negative 2 is going to be minus 4x squared. Now remember before the whole thing I made about the subtraction. So the way I do it, not only do I write in the subtraction, and what the book does is it writes the minus and then it just puts parentheses around it, and it's like, and you can clearly see we're subtracting here. That drives me nuts because no, it's not clear. So what I do when I do this is I'm going to change the sign of everything, and I'm going to circle it when I change the signs. So this is now a net minus 2x cubed or negative 2x, and now this is a plus. Now with my green marker, I can clearly tell I changed the signs, but when you guys are writing in one color of pen, sometimes your brain will trick you and you're like, did I change the signs? I don't remember. Circle them when you've done it. That way you don't do it twice. The real pain is people will often remember on the first term, but they'll forget on the second or any other terms to change the sign. So it's really the second one you got to watch out for. And now we do the actual add the like terms or subtract. So the 2x cubed and negative 2x cubed cancel out as they're supposed to. And now we have minus x squared plus 4x squared is going to leave us with 3 still x squareds. Bring down the next term. And back to the top, figure it out. X times what will get me to 3x squared? All right, well, I know I'm going to need a 3, and it would be a positive 3 to get the same thing. I already have 1x, so I just need one more. And you're going to notice on the top of these that they're going to go in what we call descending order. So x cubed divided by x would give us x squared. And then all the terms after that are just going to go down by 1 power. So x squared, then this is x to the first. Then we're going to see a constant term, and then there's going to be the remainder. Now, if you're dividing by something a little bigger, how many terms you have at the end can get a little weird. But there is what we're going to multiply by. So 3x multiplied to 3x, multiplied to x minus 2 gives us 3x squared, which we wanted to see. And then minus 6x. Change the signs. Combined, those cancel out as they should. Negative 12x plus 6x's is negative 6x's. We bring down the plus 6. And once more, x times what gives me negative 6x? Negative 6. Then we multiply. Negative 6x, and now this is a plus 12 for the moment. Don't forget, we got to change the signs. When I'm changing a positive to a negative like this, I like to just sneak it up in there. So 6 plus negative 12 is going to be a negative 6, and that is our remainder. Two ways to write it. I like to put a plus here, and then whatever the remainder is goes on the top of the fraction. And then the other part, the divisor, what we divided by, the thing on the outside here, is what goes on the bottom of that little fraction. Alex, though, is instead going to ask you to type these in as two separate things. So these three are the quotient. So basically everything before the remainder that you got as your answer part result on top is called the quotient. And then the remainder is actually often just considered the number part, the part on top of the fraction and not the whole fraction. It's kind of hit or miss to know which way is which. But more often than not, when you have to use this process, the fraction is the more important part. Like knowing the whole thing, not just the number that goes on top. All right, but that whole thing is our answer. I'm going to write it off to the side just to be, here, I'll write it down here, just to be very clear what the solution is here. So it is all of it together, the 2x squared plus 3x's minus 6. And then because we're doing plus a negative, you could just write minus in the fraction, but I prefer keeping the negative on top just to be very clear that you should see a plus here. So, little on the ugly side, but it's doable. We can see what the answer would look like. And we end up with something that is 1 degree less than our original dividend, which since we're dividing by a linear first power factor, that is what we should see. And then the terms decrease by that down to our weird remainder. So why stop at 1 when we can do 4? But first, words. So here we have the same words I've been using here. They are just more formally defined for us. So the dividend is the thing that we are dividing into. So it would often be the top of the fraction. So this might be written like up here. Another way to write this would be f of x over d of x equals q of x plus r of x over d of x. So I just took the result they had here and divided everything by d of x. So the way we write our answer looks like this. But if I want to check my result, I take my quotient, multiply it by the thing I was dividing by, add just the remainder, the top part, and that should get me back to the original function. So just to complete, dividend is going to be the top thing here. The divisor is the bottom thing, which actually shows up twice in my fraction, just once up here. Then the quotient is the first part of the answer that Alex typically asks for. And the remainder. So here they said the remainder is r of x, which means it's only the part on top that they're calling the remainder. So in Alex, you're going to type the quotient, and then in the other box, you will type just the part on top. Now I do put out a caveat that sometimes the questions get programmed weird, so just pay attention in case it gets mad at your answer. What I like to do is I'll look at view an example and just click till I get to the end and see how they typed in the answer. Just to know, was I supposed to type a fraction here or not? What is the answer supposed to even look like? All right, so now more of the same. We're just going to keep practicing. So the other catch to these long division questions that the book and Alex seemed to do a bunch was they messed with the order they wrote stuff down in. So our divisor on the bottom typically doesn't get messed with, but what they write on top can. So when we do long division with numbers, you can't rearrange the digits, the numerals in a number without changing the number. So, but in polynomials, if I rearrange the terms, it's still the same polynomial. It doesn't matter the order I write them in, except for when you're going to do division like this. So when they are not presented in order, as we can see here, I have a fourth power term as my biggest term. So that is our first step, is actually rearranging the polynomial so it's in our biggest power to smallest power. All right, so we are still going to divide by 2x plus 4. We're going to divide into. So 6x to the fourth is our big term. Now, the next term down, you have to account for every term that is a smaller power than x to the fourth now. So I need to see something in the x to the third position, something in the x squared, something in the x, something in the constant position, each of those. Even if I don't have a term in the original polynomial, I got to put something. And in this case, the something I can add without changing the value is 0. So since there are no x cubes in the original, we are going to add 0 x cubes. And the book does this on far, far too many of these. So just FYI, expect to have to put at least 1 0 in there. Now we have minus 20x squared. We have no x's, so I'm just going to put plus 0 x's, and then minus 16. Then I'll just extend that bar on top. All right. So now things get a little more interesting. Still works the exact same way. It's just now our front term is 2 x's instead of just an x. Still think through the same way though. I have 2x. What am I going to multiply that by to get to 6x to the fourth? So it would be 2 times 3. And then I have 1x, so I would need 3 more. And just roughly x to the fourth divided by x would be x to the third. So that is what we expect to see as the highest powered term. All right, now we multiply. So this is 6x to the fourth as desired, and 12 plus 12x cubed. Cool. Minus. So now this is minus 12x cubed. And we bring down our next term. All right. So 2x, and I'm looking at negative 12x cubed now. So I need a minus 6 and 2 more x's, so minus 6x squared, which we should not see like terms on the top of. So if you find yourself writing the same power twice, like pause, take a step back, and be like, they shouldn't be the same power. Something's wrong. Multiply. Negative 12x to the third. And now this will be minus 24x squared, which is starting to look a little big, but remember, plus. No, it's not so bad. Just 4x squared. And 0x is just as a placeholder. So I'm going to need a plus 2, and I'm going to need another x. So we have 4x squared. wrong color. 4x squared plus 8x. Yeah, after a while, using the colors on every step gets a little tedious. I still find it really useful when you're still getting used to all the steps, though, because it helps you think of each step as its own process, as its own thing, and they don't get as mixed together. But when you get more fluid with it, like you'll see what I did. I kept writing in the same color because I was just like, and then we do this and this and this, and changing colors just didn't occur to me. And we have minus 8x. We're going to bring down the crazy looking minus 16 now. So I have the x already. So I just need to multiply, figure out the number. So that would be 2 times negative 4. So we're going to write minus 4 up here. All right, so negative 4 times 2x is negative 8x's. And 4 times negative 4 is negative 16. Why am I making funny? And see, I just wrote it in pink. I'm just going to leave it. So this becomes a plus. This becomes a plus. And we actually end up with 0. This happens. In fact, later on, this is what we want to happen. We like the zeros because it tells us something special about the function. So this is where I'm going to zoom back out. Remember our whole writing the division algorithm? I can write my quotient times the divisor plus the remainder, but the remainder is 0. So this literally tells us the original function is equal to the product of the divisor, 2x plus 4, and the 3x cubed minus 6x squared plus 2x minus 4, the quotient. So 2x plus 4 is a factor of our original large polynomial. That's what that means, because I can actually write it as this thing here is the same as 2x plus 4 times the stuff on top. 3x cubed minus 6x squared plus 2x minus 4. If I boxed those together and worked it all out, I would get back to this original 6x to the 4th minus 20x squared minus 16. Not bad. Okay, so we've done another one and we saw what happens when we get a 0. It's okay to get a 0. Now, we can also use division for dividing by something that is not just linear. So up till now, we've been dividing just by x's or x's with numbers in front of them, but the x hasn't had higher powers. Long division doesn't really care what the powers are as long as the top's bigger than the bottom. So in this case, we're dividing by a squared. But remember, find the zeros first, account for all your zeros, because Alex is a pain like that. All right, so going in, we have not just x squared plus 5, but we have a missing, not visible 0x. So the multiplying onto the 0x is going to look silly, but we're going to need that as a placeholder to make sure that our like terms are lining up. So it can be done without it, but the work gets a little messy. And then inside I have an x to the 5th. Then I see 4x to the 4th. Good. But then I am missing x cubed, so shoehorn it in there as a 0. Plus 18x squareds minus 20x's minus 10. Good Lord. And this is why I quit typing, because I always have to extend the stupid bar, and this way it's spaced correctly. Now, because we're dividing by a quadratic, it looks like, oh, it's going to be many more steps. It's not. It's actually still only going to be 4, because we're going to get a cubic, a squared, a linear, and a regular number. So the first one actually works out really nicely, because we have 2 x's, we want to get to 5, so we need 3 more. Now, where you write this on top, like back when we did number division, like we were very insistent about where the number went, like what number it was over, because that was indicating place value. But if you wrote 1000 and then 300 above it instead, then which number gets written first or second doesn't matter if you're paying attention to that place value. That's why I haven't been too particular about where do I put this first term. I just put it on top because it doesn't matter. But you could line it up with the x cubes if you want. Multiply x to the 5th plus 0 x to the 4th. And see those line up, and then plus 5x cubed. So if you ever do the multiplication, if you forgot the 0x out there, you'd have a 5x cubed under a 4x squared, and they're not like terms. So if you see that, be like, but it is like terms with the x cubed that I hopefully remembered to write. Let me change the signs on everything. Not that changing it on the 0 does anything, but still. Completion. So 4x to the 4th. And now this will be minus 5x cubed. So we get 2 terms as the result of this. We are still going to bring down the next term because I'm dividing by ostensibly 3 terms. So I need to see 3 terms. So I have 4x to the 4th and just 2 lonely x's. So plus 4 and then x squared, which follows our descending power expectation. So we multiply. This is now 4x to the 4th plus 0 x to the 3rd plus 20x squared. Change the signs. Minus, minus, minus. And this is now minus 5x cubed. And this is just minus 2x squared. And then bring down that minus 20x. Scoot this up and do it again. Negative 5x cubed, so I need another x, and I need that minus 5. So minus 5x. Minus 5x cubed. Plus or minus, it doesn't matter, but it's still a 0. X squared minus 25x. No. Change the sign. Immediately stick with green for that. Plus and circle. Minus, not that it does anything in circle. And circle. So the first 2 cancel out, so we have minus 2x squared. And now negative 20x plus 25x leaves me with positive 5x's. And the last term of minus 10. So to go from x squared to negative 2x squared, I just need the number, minus 2. And the last part will be minus 10. Oh, interesting. Ooh. Change the signs. So the first term and the last term cancel out. So the only thing we're actually left with here is 5x. So that is our remainder, just 5x. There happens to be no constant in the remainder. Normally there is, just kind of fluke it worked out this way. But we have that as our result, plus 5x's over the original divisor, x squared plus 5. Now, just because you see 2 5s does not mean they cancel. That is all we can do with that. Remainders, unless you noticed a common number between the top and the bottom that you can divide everything by, it's not going to reduce. And there's our ridiculous answer. Again, in Alex, you'd type the red part and then just the 5x most likely. Now we get one a little more interesting. X to the 4th minus 81. It looks so nice and cute. It's going to be a little long, but this is going to lead towards the next video with synthetic division. I do want to point out the one we just did with the x squared plus 5 as the divisor. You cannot do this with synthetic division. Any squared or higher powered divisor thing on the bottom you're dividing by. To do synthetic, it must be linear and it must be just x, not a 2x or a 3x. So sometimes you are stuck with long division. If you're planning on going on to pre-cal and calculus, this does pop up again just a little. So don't totally neglect it, but don't spend forever on it either. You got other concepts to learn. But this is going to pop up when you do the rational functions and start talking about asymptotes. And then we're going to be talking about rational expressions and equations in the coming weeks as well. So here, first thing is the setup. I slept, honest. So we have x plus 3 on the outside, and then, wow, yes, it needs space. Because I have to get all the way from x to the 4th to the constant 81, but I got to go through all the powers to get there. So we got a lot of zeros coming up. So there are no x cubes. There are no x squareds. There are no x's. But there is an 81. So this should actually work out pretty nicely, but you'll see. It's kind of interesting the way it happens. All right. So I'm going to need an x to the 3rd. So I have x to the 4th plus 3x cubed. Change the signs. So minus 3x cubed, and bring down the silly 0. Just need it as a placeholder. That's why I'm calling it silly. So now we've got negative 3x cubed. Start it again. So minus 3x squared. Sorry, when I've done this in the past, I haven't had the 5th color, so the first 2 steps ended up the same color, so my brain will kind of default to that. All right, now we have minus 9x squared, but we're going to change our signs and circle. So it now becomes positive 9x squared. And we're going to bring down that 0x. Nope. So now we are going to need positive 9 and still an x to get to 9x squared. But now this will be plus 27x's. This becomes a minus, and this does. So we now get minus 27x, but we also get minus 81. So to take x to negative 27x, we're going to multiply by minus 27. So we get minus 27x minus 81. Huh, look at that. Now you guys are going to have more than one of these on your homework. And in fact, these actually show up in your college algebra assignment. But here, everything cancels out. So it turns out that x plus 3 gives us a remainder of 0. So that means x plus 3 is a factor of this crazy mess. X to the 4th minus 81 actually has a different way. You could actually factor it as a difference of squares. You get x squared minus 9, which factors again as a difference of squares, and one of those factors is x plus 3. And then you get x minus 3, and then you have a quadratic that has factors, but they're imaginary. You get 3i and negative 3i. So a lot of 3's here. All right. So that crazy mess on top is what we get after we do the division, or we could write the x to the 4th minus 81 as the same as x plus 3 times the whole x cubed minus 3x squared plus 9x minus 27. All right, that is it for this video. Next up is going to be synthetic division.